Today we will make slip ring motor starting. Slip ring motor have the stator winding usually in delta. We'll connect the windings in delta. Line 1, T1, T6, line 2, T2, T4, T3, T5, line 3. And the rotor winding basically is short circuited from one side, and the other side is from the rotor terminals from the slip ring bars. We can add power resistors here to control the RPM of the slip ring motor. It depends on the value of the power resistors. It can be variable or in stages if the motor is bigger. So connect how many resistors, or if manually done, you can vary that one manually or by automatic means. Here we will do the main control of one set of power resistors. So by one stage only. First, we are going to connect the rotor terminal to sets of power resistors and short circuited them by star connection. It will lower the speed of the motor during the initial stage, at the same time lowering the starting current of the main winding or stator winding during the starting stage. So another starting method of starting induction motor, this time using a slip ring type motor, a motor wherein the main or stator winding and rotor winding are separated. This is not an ordinary squirrel cage motor, but a wire-wound rotor winding motor, or sometimes called slip ring motor. First, we will determine the sequence of the operation. Again, from the previous diagrams we have almost the same. Basically, they are the same operation by identifying the contactor sequence here. Let's say contactor 1, contactor 2 in operation first, then contactor 2 cut off, then take over by close transition contactor or contactor 3, leaving the rotor winding short circuited. So it will become an ordinary induction motor or equivalent to a squirrel cage motor. So thereby starting the motor at low starting speed with low starting current. Then if the motor is already in starting, after the starting, this will short circuit the rotor winding and make the motor in normal RPM. At the same time, normal operation. Well, it depends on the motor size, and this resistor starter will be computed. First, we are going to connect them, determine the sequence. K1 and K2 first, then K2 turn off, CT turn on, then K2 will be interlocked. We are going to short here. So the winding initially is connected to the power resistors via K2. So stator winding, rotor winding, turn on, turn on. After some time, this will take over and this is interlocked. So again, close transition because this one is open after this one is closing. So we will connect them. Identical circuits from the previous applications. And the timer is here. So why the circuit is recurring? Because we have the same sequence, K1 and K2. Then this one turning on and turning off this one. You can test this one. This one overlapping of connection, but that is fine. And outside the working area. Okay, see here, since I put only 1 second there, we will stop the operation so we can see. Turn off, turn on. Okay, time. So main winding and the rotor winding, of course we don't have supplier, this indicated as close also. In reality, of course, there is magnetic connection, electromagnetic connection between the rotor and stator. Okay, then this will close and open this one. Okay, close and open.
This will act as a squirrel cage type motor. Starting current 81 RPM. You can also decrease the RPM. Need over resistance. Turn off and get the starting current. From 0.81 to 0.26 using the middle resistance. You can further decrease the RPM. It depends on the application. So the lowest RPM here is 1900. You can start the motor at the desired resistance. If the resistance is very high, the motor might not start.
In this case, if we are going to add the resistors because the motor is big, we are going to have more resistors here, for example. So we will add power resistors in stage operation. The same in power resistors or motor starting using power resistors. They are basically the same, but this is secondary starting. The resistor starting previously was installed in series with the stator winding. So we call that one as primary resistance starting. Sometimes it is called that way, and this one is called the secondary resistance starting because of the rotor winding being series with the power resistors. And we can manipulate this one, add contactors and timers, and make it sure it is also in close transition. We will add contactors let's say how many contactors. If we add, if we will add, let's say one set of power resistors, so we will add another switching contact, three switching contact of contactors. So first, this stage two resistors in series. Next, we are going to cut off one resistor. How to do that? By cutting off this one, one, the bottom one. So we will connect here. We will connect here. Okay, then we will have, we will make this one as CT2 close transition to, okay, the last contactor. We just name them resistor, resistor of, or RO, RO resistor of, whatever label you want, just document it. Then let's say R1 resistor 1. Two resistors in series, okay, R2 resistor 2, I2. Wait, this is R1. R1, the bottom one is R2. Two resistors in series, that way. Okay, then we will change this one R2, and then RO plus another conductor. We need additional timer here, of course. You can move this one. The power resistors here again are for motor starting. The bigger ones, wire one, sometimes they are in package designed for motor. Runs out negative or line 2. What we are trying to do here. Find the sequence. First, turn on this one. You can turn them all together and cut off after this one. I mean, 1 and K1. After some time, this one, they are in on. It's a span of 3 seconds between them. They will turn on for 3 seconds, enough to handle the starting current of the motor. Of course, we are going to calculate that based on the specification of the motor. And this one will take over and cut off the two in close transition. So we will add the interlock later. And who will turn this on? Are they independent with this one or dependent? Let's say turn on this one and this one. Okay, they are parallel with this one. So this one is the controlling auxiliary contact. 1 and 2 on, then with the timer turning on this one. Let's say 1.5 second turn on, cut off one resistor, then only one resistor, then another time turn this on, then later cut off the two. So you can have the sequencer. You can write the conductor sequence. K1 and on K1, what else? On K1 and R2 and timer 1. How many devices are on initially? 1, 2, 3. Okay. After sometimes turn on R1 by the timer. We need normally close, I mean normally open contact here. Who will turn this one? T1. This one is T2 now. Timer 2. Okay. We will test. But why there is duplicated? There should be one label only. R1 or is R1? R2, R1, R0, timer 1, timer 2, timer 2. Let's say 1 second. Okay, no more red notification. We will add the interlock or other contact later. Okay, turn on this one and this one. Then we have to turn this on. Then cut off. We have to turn this on first. Then cut off this one. Who will turn this on? This one is dependent here. Okay. So after some time, this one will turn on. Then we will interlock the R2 and timer 1. So timer 1 is connected here so that we can interlock them together. Only one contact here. Okay, we will see. There are several solutions. It depends on how many contacts you are using. You can add as many contacts as you want. As if you are designing, you can streamline that as long as it satisfies the safety and function. Is I guess I am using RO there, not R0. It should be 0 because I am using 0 on the other side. This is 0. So that's why it will not detect, the software will not detect it not the same label. Okay, okay. No, we are not keep turning off because now interlock. We are going to interlock this one. Again, the motor is in close transition because always the motor is not open here, close. The rotor circuit is always closed. But do we have a current there? No current because you have resistor. It is now short circuited. This will act as ordinary induction motor. It's equivalent to a squirrel cage motor because no more resistance. Then we are going to interlock this two and cut off this one. Since this will be cut off also, we are going to latch this one, RO. Need a latching contact here. And this is RO. Use as many contacts as you want in the initial circuit. Then you can streamline them if you are finding now the solution. Because or if you add so many contacts, you will add also the auxiliary contacts or the extension contacts. It will cause you more. We need to interlock here. Of course, you are going to test that in actual. Have your testing room test this one. Maybe there is a slight difference in the operation. You can add contacts. You can add safety features, the lamps, the metering instruments are make it safer. One, two, three, cut off. Okay, that's why we need this one because it will also cut off this one. We can step this one step by step. The software memories that one, but there is no power there. Okay, time. Two resistors in series. Stage 1. Stage 2. Okay, now this one is cut off because we are short circuiting that one. So only resistor number 1 is connected now. Next, we are going to cut off the two resistors. Okay, in closed transition, the circuit is not open. Then it will start opening now. Okay, open 1, 2. But at that stage, no more current there because this one has no resistance, so the dominant current is there. So this is it. Again, the overload relay is connected here. We can simulate overload relay. You can add lamps there, signalation lamps. Slip ring starting method. Yeah, starting method for slip ring motor using power resistors. Thank you for watching. Please subscribe. Please support. Thank you. May you have a happy day.